Number 4 in the exercise section 1K. The sum of an infinite geometric series is 3 times the first term. So let's write that down in mathematical symbology. So the sum of an infinite geometric series, the sum of all its terms, right, is 3 times is equal to 3 times its first term. Okay, we know this. We know this so far. Period. Find the common ratio of this series. Find R. Okay. There doesn't seem to be enough information to solve this problem. But let's see, maybe this is enough. Maybe knowing this is enough if we also include in the analysis what we know, right? Which is that the sum of all the terms of this infinite geometric series should be equal to the first term over 1 minus r. Okay, now look at this equation that we have here and look at this equation that we have here. When you have many equations, you can play with them and see if you can actually mix them, so to speak. If you notice, guys, I'm telling you here that this thing is equal to 3u1. So you may think of putting this value in there. And let's see if that produces any meaningful or useful result. So let's see. We have this. After that substitution, I'm going to continue here, right? Then I'm going to multiply both sides by 1 minus r. This is just basic algebra. 1 minus r equals u1, right? That's all I did. Then let's keep on simplifying this. We're going to have 3u1 minus 3u1r equals u1. Then I'm going to subtract this one from both sides of the equation. So it's going to be 3u1 minus u1 minus 3u1r equals 0. Then I can see that all the terms have u1. So we can factorize. We can factorize in this way. u1 that multiplies 3, that multiplies minus 1, that multiplies minus 3r equals 0. And then here we can simplify 3 minus 1 into 2. Like so. It's just algebra. If you're having trouble understanding any of the steps in here, just pause the video. Pause the video and look carefully. Okay. So let's see. What are we having here? We have this equation, right? We have this number. We have this number that multiplies this number, and the product is 0. We told you in the first semester that when you have this in mathematics, when you have the product of two numbers, and such product is 0, then either the first number is 0 or the second number must be 0, so that the product is equal to 0, right? So let's use this fact for this. So I can write this: either u1 equals 0 or 2 minus 3r is 0, right? And when you solve any of these equations, well, this one is already solved, right? This is the solution, u1 equals 0. And when you solve this one, guys, when you solve this one, you're going to get that 2 equals 3r, and that, in the end, r equals 2/3. And that's how you find the ratio, by this process of reasoning. Okay, that's what they asked you. Find the common ratio of this series. Here it is. It's gonna be 2/3. Now, if you want to confirm, then just substitute everything, right? We have the following. If you substitute 2/3 into wait, okay, let me erase everything right now. I don't need all the stuff. So we found that the ratio is equal to 2/3. Okay, this was the finding. And now let's see. The sum of an infinite geometric series is 3 times the first term. So give me a moment. You know this, you know this, and therefore you can actually find the U1, right? In this way. You can substitute in here the 2/3. Well, no, this is gonna be a no, forget about this. Forget about this. I was going nowhere with this. I was going nowhere. So this is the result, right? This is the result. Defining through the reasoning process that I told you about. That it's that simple. It's that simple. Okay. And once again, try to replay the whole thing if you want and understand each of the processes I went through in order to find this result.